Hello everyone. Here is a trick for graphing parabolas. This is similar to using a gradient, but there's something you have to understand. Since it's an exponent, you have to change the gradient every time at every point. I know that sounds confusing, just keep watching and I'll explain it. First, I want you to understand this pattern. 1 squared minus 0 squared is 1. 2 squared minus 1 squared is 3. 3 squared minus 2 squared is 5. 4 squared minus 3 squared is 7, on and on. So you can tell by this pattern that it just goes 1, 3, 5, and 7. Wait, let me just check if I'm recording. Okay, yeah, everything's good. So it's a pattern of just all the odd numbers. If you see here, 1, 3, 5, and 7. Now, I'm just going to use a graph to show you this. And first, we're going to try and graph this by ourselves. And then I'll show you how to, then we'll check. So, if we used standard method, let's just say this is 1. Okay? 1, and it was, say it's y equals x squared. Well, 1, you have to think 1, 1. So that's 1 squared is 1, so we put that there. 2 squared is 4, so we have to put that there. There's a bit of calculation, but I'm going to use the trick that we just saw to help us. So you don't really need to think about this. You just got to think of that pattern 1, 3, 5, and 7. And I'll show you what I mean by that. So first, we increase by 1. Alright, so 0 to 1. Then we increase by 3. So we move 1 up the run, but rise 3. So that means 4. Okay? Because we go 1 to 2, 3, 4. Then we go up 5. So we go up 1 run, 1, 2, 3, 4, 5. And we simply do this over and over again. 1, 2, 3, 4, 5, 6, 7. So if I was right, that means this point should be 15. Let's check. Let's put this as 1. Well, looks like I was a little off. Yeah, I think I might have included 1. But if we check again, 1, we run 1, 1, 2, 3. We run 1, 1, 2, 3, 4, 5. Wait. We run 1, 1, 2, 3, 4, 5, 6, 7. And this is a simple pattern for if it's only 1 times x, if it's just x squared. Plus any number, plus any constant, all you need to do is just say we make constant 2. You just start from that point. So we just go 1, 1, 1, 2, 3, 1, 2, 3, 4, 5, and so on and on. For the b, which is the x-intercept, oh shit, wait. Never mind. See, this works not in a quadratic form. You have to factorize it first. So you need to make it something, bracket x plus or minus something, either square it or not, plus by c. And then you just get the x-intercept, and then you do my standard rise method. And there is something you need to know. If a is a coefficient, you have to times that by each rise you do. So let's just turn this off for a second. Let's say my a is 2. Well, that means I'll first have to go up by 1, but I have to times the amount I go up by 2. So I go up 2. Now, see here, I would go up 3. But since we have to times it by 2, we go up by 6. So now we're going by 6. So 1, 2, 3, 4, 5, 6. Now we would go 5. But now we just go up 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's see if this is right. Well, bam. This also works if it's a decimal. So say we want, this works for -2, okay? So you just gotta write it down. It's kind of like when you have a straight line, you got the intercept slope of the straight line. You know, you have your gradient. Whatever the gradient is, you just rise or you go down, depending if it's negative, by that amount, and you always run by 1, except if it's a fraction. It's the same thing here, except you just times it by the coefficient, and you have to always go by the odd numbers, because what I said, that's the difference of consecutive exponents. So let's go down one. Then we go 1, 2, 3, 1, 2, 3, 4, 5, and you just go on and on. Now, I'm gonna be honest here. It's kind of less useful if you got something like 1/3, because really this is a method to get rid of calculation. You just count up. But it's still, I find in my experience, it's still faster to do it this way and then times it by the coefficient rather than thinking, oh, what's 2 squared, then times it by 0.3. You just get the number and you don't have to think of exponents at all. So we go up by 1, and see, we're supposed to go up by 1, but we times it by 0.3. So so 1 by times 0.3 is 0.3. So we just go up by 0.3. Then we would go up by 3 and times it by 0.3. That would be, well, it's not 1/3. I was going to say a third, but it's close to 1. It's a little above. I think it's 1.33, and we go up by that. And you simply just keep going up and use my method as I stated before. And when there's an x-intercept, I don't know if this resource, I just found this like a few minutes ago. I could try, if you guys want, to explain this. Say, instead of x being here, it's like on 2. Let me see if that works. Yeah, it doesn't really work. It changes the vertex and everything. I don't even know how this works. But if you guys would like to if you guys would like me to try and find another resource similar to this, that I could show you what you do with an x-intercept to show you it still works with that, because I've tried it and it does work, then just leave a comment down below and I'll see. Before I end this video, I just want to see, is there actually a way to make it like that? Wait, yeah, here. Standard form, vertex form, let's just go standard. Yeah, that was the one I had. Let's try vertex form. AX, oh, there we go, there we go. So, this is simply, say I have H as 2, that means X would be 2 to make it equal 0. So, if we just use normal, let's just make it have no, like, just make it 0. So, we can try to and look at the points ourselves. We just start at the vertex, the beginning point, and then we go on from there. So usually, let me just zoom in a bit, we would go up by 1 run and 1, because that's where it starts. Then we would go up by 3, 1, 2, 3, then go up by 5, 1, 2, 3, 4, 5. Let's check if that's right. Oh wait, 1. Bam. You don't even need to look at the numbers or have good graphing skills. You just got to count up the lines. And all I want you to remember is, you don't even need to remember, I figured this all out by myself. You don't even need to remember that it's different with exponents. Just when you're graphing, you remember the odd numbers. You just use odd numbers, 1, 3, 5, 7, 9, 11, 13, on and on. And when you have a as a coefficient other than 1, just times it whatever number you want to go up by that coefficient. So say this was 3, okay, instead of going up by 1, we would go up by 1 times 3. And instead of going up by 3,